So, the gig, why don't we start just introducing to the audience what Zoomdata is?
Yeah, so Zoomdata is kind of a new take on data reporting, visualization, and BI, and really focused a lot on the human factors of how normal humans, not necessarily data scientists, but how most normal business people should really be interacting with data, especially on these kind of new types of devices that we have, touch devices, mobile devices, even kind of farther out stuff like augmented reality and virtual reality we're starting to kind of look at and think about.
Okay. So there's a question. I mean, you guys obviously, one of the things you pride yourself on, you have connectors to a lot of different technologies and so forth. And I've seen over the last, say, year or so forth, you've invested more and more heavily in Spark. It's becoming an integral part. I'm curious, what led to that? What is it? What are you seeing in Spark that it's good for as you built on top of it?
Yeah, so we really look at Spark not as something to connect to, but as an engine that we're actually running all of Zoomdata's operations on top of.
Okay.
So we actually now depend on Spark as Zoomdata, and we ship a little tiny Spark with each Zoomdata deployment, but then that can be pointed to an external Spark cluster for greater scalability. And what led to it is that when we started running queries on bigger data stores, like Cloudera's data stores, we got these result sets back, and we needed to take these result sets and very quickly resort them, pivot them, change pages, without going back to the kind of big data backends. And so we needed a fast place to kind of put these data sets. And then when we started needing to join data together from different data backends, we figured that something like Spark would be a great place to start to do that too.
Got it. And so, I mean, I know you pride yourself on rolling your sleeves up and getting there. What were some of the challenges? What were some of the hard parts as you were developing on Spark?
Yeah, we really run into a couple things around kind of user concurrency, because our scalability profile, we could have thousands of users all interacting with multiple visuals all at the same time. And those are all generating little Spark jobs. So I think that scalability profile is a little bit different than most people using Spark. So we need to be able to support hundreds or thousands of little Spark jobs that might take less than a second each, running very quickly. So we run into some kind of concurrency things. We run into context sharing. How do we have a cluster of Zoomdata machines all be able to share data that might be in a single Spark context? And also just pure speed. One of our things for human factors is the humans want the results as fast as possible, and that means milliseconds in a lot of cases. And we found that Spark is gotten a lot faster, and things like Project Tungsten and other things that we talked about, we're hoping will really drive that.
Got it. Okay. And then what's on your wish list? Because you're incorporating more in Spark, right? As you said, you saw Patrick and Matej's talk on for the next 6 months, 12 months. You're like, if they could get this would be awesome. Beyond just make it faster.
Make it faster. Yeah, I think we're really kind of thinking about a lot of collaboration type things. Like, how do we take the work that these data scientists are working on in these notebooks? How do we kind of take that work and expose it to the rest of the broad business audiences in a way that they can kind of see who created these machine learning algorithms or scoring algorithms or stats functions or whatever? How can that be exposed to the regular people? And how can we kind of create this kind of network or grid of both normal people as well as data scientists kind of collaborating together within an enterprise or within whatever around data? So it's kind of something that we're starting to see a little bit inside Databricks notebooks, so like the GitHub stuff and the collaborative stuff. But that's an area that I think we haven't talked much about as a Spark community, is how do we kind of enable that collaboration?
Got it. And so let's build on that a little bit more. I mean, how do you see BI and visualization changing in the era as Spark and big data in general takes off? Is it just the same, just with more data? Is there any kind of differences that you're seeing trend-wise?
Yeah, we're kind of looking at kind of doing it the opposite way. I worked at MicroStrategy in the mid-90s, and it was like top-down. You'd start with a CIO or whoever CEO. You'd interview them. What are your organizations? How do you break it down? What kind of dashboards do you need? And what we saw at Tableau did when they went to market was they started kind of the opposite. They just gave the software to people running Tableau.exe, and that really kind of changed that paradigm. But what we really are trying to do is kind of do that to some extent, but then be able to kind of weave that together and actually have the system kind of learn from what one user does. You can actually intuit a lot of stuff about the actual data, then start to kind of roll the system up from a grassroots level and learn from what the users are doing and try to bring that kind of up the other way. And if you kind of zoom up, like our name Zoomdata really came originally from being able to zoom all the way down through your organization, then zoom all the way back up. You can kind of have it kind of see it self-assemble back up. So when you zoom all the way back up as a CEO view, you might actually see the way your organization is like really laid out based on what metrics people are actually using, what data sources they're actually using, and how they're actually thinking versus kind of that top-down approach.
Got it. And kind of maybe a slightly different angle on that. I mean, one of the things that we've seen happen in other industries is that as use cases become more well understood, we see a lot here today. This is what they're doing, X, Y, and Z. There's a some people say that there's a focus more and more towards domain-specific, basically, application. So how do you see that trend going? What role does BI and visualization play if the world does move towards more and more domain-specific
Yeah,
applications?
we're seeing a lot of embedding of BI into other applications.
Okay.
So people are building data-driven services or data-driven applications. One of our customers has launched a fashion industry portal. It's real-time streams of data about fashion trends, purchases, colors, styles, availability on all these e-commerce websites.
Yep.
And these fashionistas, or whoever, I guess, are the end users, want to like use this to understand real-time fashion trends to react to it. So we're seeing BI kind of need to be embedded in those domain-specific applications, and we've done a lot of work to be able to try to do that. And eventually, I think kind of BI almost fades away as an interface that you kind of buy specifically, or even a category of technology that you might even talk about in the future.
Yeah.
Because almost every other system or interface that you use needs some embedded reporting charts, dashboards, ways of looking at data. So it's an interesting question for these big enterprises as they're working more with cloud applications. Really, does all the BI need to come into one kind of tool, or is it spread out across lots of tools? And if it is spread out, how do you then roll that back up again into kind of higher level views?
Got it. So, slightly different question. So you mentioned early on that you're using Zoomdata, you're embedding Spark in it, it can kind of fuse a multitude of data sources.
Yeah.
From what you're seeing with customers, what are some of those popular data sources, and are most of your customers single data source that they focus on from what you've seen? Is it multiple data sources? Because you mentioned Fuse, it would seem to imply that there's a fairly distributed set of data.
What we're seeing in the real world is that people are getting these data lakes and data hubs, and they're putting a lot of their data in there.
Yeah.
Oftentimes they're putting their fact data there, but they're not putting their dimension data or their lookup tables there.
Yeah.
So a very common kind of simple case of fusing data is I have my fact tables here with the SID numbers, and I have my lookup tables maybe in Oracle, my customer tables in Oracle, because that's a system that's been set up a long time ago. But they want to be able to bring that together kind of on the fly for the users without having to kind of wholesale be replicating that Oracle table into Impala or something like that. So that's a simple use case. Then we see people deploying things like MongoDB, things like Elasticsearch, Solr, like all these different kind of specific engines that can store and query data to certain degrees, as well as cloud-based data. Most people have data within their enterprise, and they have data in Redshift or somewhere else, and they want to be able to kind of bring all this stuff together without necessarily kind of pre-thinking the model, and definitely without kind of moving it all in advance into a single place.
Got it. So, I mean, on that point of cloud, right? BI can only work wherever the data is.
Yep.
So, what are you guys seeing as trends? I think you mentioned there that it's mostly separated between a little bit of on-premise and in the cloud, or is it a shift one way or the other? Specific workloads that are better suited for one or the other? Yeah,
I think BI is still mostly an on-prem kind of thing, but a lot of people's on-prem now actually means actually in the Amazon cloud or somewhere like that. So they're thinking of it, since it's all VPC'd and secure, as it doesn't really matter whether it's on-prem or in the cloud, but the point is they want to manage it, they want to control it, they want to secure it, and that might mean instead of setting up their own servers, they want to manage those Amazon servers very, very tightly. So we're seeing cases where people have part of their data in the cloud, part of their data is in Salesforce, part of their data is in Google Analytics, part of their data is in legacy systems, part of their data is in these new systems, and they need a way to bring it all together. And that's what we found Spark very, very useful for, because through Spark SQL external data connectors and other things, we can reach through to all these kind of different places, and then roll it back up using Spark SQL, and then present it to the users through Zoomdata.
Got it. So one thing I've always been curious about from a BI perspective, now you're building the application on Spark, is a lot of the BI applications back in the day was, well, they were working on top of a SQL-oriented database, so they just generated SQL and so forth, more natural queries. Now you have something like Spark, where one of the worries of always of BI tools is, are you leaving a lot of capabilities on the table? You're not touching the graph computation capabilities, machine learning, and so forth. So I'm curious, what your take on that? Will it over time be allowed to pull more and more of those into the BI in a seamless way for users, or no, that's kind of the domain of applications that are written directly against Spark and not really in the BI format?
Well, that's our benefit of being a relatively younger company. We started on Spark, so we didn't have anything kind of before that as a server or as an engine. So that means we needed to start with basic reports and graphs, but it allowed basically structured data, but it lets us get quickly into semi-structured data, into graph data. Our connections to Cloud Era Search, Solr, and Elasticsearch give us a lot of kind of semi-structured, unstructured capability. So we really see the ability for humans to be analyzing data in kind of traditional BI views is interesting, and we also see the ability to analyze graphs and networks of data is also very interesting. And the goal is to kind of get that and the machine learning and the stats like all into the hands of these normal people, so that they can see it, they can they can touch it, they can explore it, and they can leverage these models that are maybe built by a data scientist, even if they don't understand necessarily how the model works. As long as they trust the data scientist that built it, they can kind of apply that and see that model applied to their data, and maybe score real-time streams of data against that model. So our trick is to design it from a human factors perspective, to make all these relatively sophisticated concepts like the stats and machine learning, and like make that visible and obvious and simple. And that's our core challenge from a design perspective in data, is how to do that.
And you realize by calling them normal people, you insult about 85% of the audience.
I'm also among the non-normal people, so we're all in that boat. But
I think we're out of time. Thank you,
great.
Justin.
Thank you.
And so forth.